Hello friends, सबको नमस्ते. So today in this video we will create a push-up counter. So let me show you the preview. For that, let me run this file. It will take a seconds to open the dialog box, or you can say OpenCV image dialog box. Okay, so this is one. It's containing three images. You can say when a person is using left side for the push-up, right side for the push-up, and the front side for the push-up. Let me select one. Let me press R here. Now it will automatically, you can say, it will randomly select one image, okay, video, and it's run it. You can say it's running right side push-up video, and it will count it. And you can say this values, or this coordinates are moving here and there, because right now I am using YOLO, you can say YOLOv8 and model. But if I will use YOLOv8 X model, it will be more stable. Okay, so let me show you how it's counting. One, here also it's moving. Okay, and these are the push-up bar. As soon as I press S, it will stop the video, and we can go to the main window. And as soon as I press L, it will select the left side. Okay, you can see the coordinates are moving, because right now I'm using YOLOv8 and model. If I will use YOLOv8 X model, it will make the coordinates value make stable. Okay, let me push up, move up. As soon as it move up, you can say the bar value will become to red also, and counter will become 1. Okay, so this way it's completed. Now let me press F for front side. Okay, here also the same problem, coordinates values, and here also the counter is not working well, because we are using YOLOv8 model. Now press S again, the main window will get closed. Now let me show you the result of you can say model which is model with the YOLOv8 X model. Okay, so let me show you one first F video. This is an example I'm showing you. Okay, see this. As soon as 1, 2, see the counter value 3. Okay, so this is it. Now let me show you for the L1 left side push-ups. 1, 2, see the bar also. Okay, 3, 4, and see this alignment. Now let me show you for the R. You can see this is the alignment, and here also it's showing the alignment, and here the counter value, and these are the bar for up and down. Okay, so this is the whole thing. We will make a push-up counter here. I will explain you each and everything here. These are the utils, the functions. This is a help function which I made for the explanation purpose only. This is not a main code. Utils and the main is a main code here. Okay, so let me explain you everything line by line. So now let me explain you everything line by line. So for that, let me comment whole code. Okay, so let me start. These are the libraries which we use first: CB2, OS, random, and from alternative YOLOs. And these are the functions, helping function, which is in util Python file. Okay, now first we have to set the background. For that, we have to get the image path. So this is our background of it, or you can say the main window, and we have to read it, then we have to show that image. Now to make this window stable for infinite time, we have to use key is equal to and cb2 dot wait key. Oh, sorry, comma will not come. Stop will come. cb2 wait key and 0 for the infinite. Now one more thing, that here I will explain you why we have to use the while loop. Before that, if suppose we do not use the while loop, what will happen? Let me run this file. It will take a seconds for wait for that. See, the window is coming. So if suppose I press L or S, as soon as I press any key, it will vanish. It will not stop for that. Or you can say the window will get not vanish, or no, window is not stable. Now let me comment this. Now we have to uncomment the while loop. Let me uncomment it. Then I will explain you how the while loop is using. Okay. Now let me comment this. I will explain you later what is happening here. Okay. Okay. So now let me explain you how the compiler will work. As soon as I run this file, it will show the image and the compiler will come here and wait for the user to press the key. As soon as the user press the key, it will see whether the key is L, small or capital L, small R or capital R, small F or capital F, or it is a escape key or small s or s key. Okay. If it is not, if it L means if a statement is not matched, it will just print this: press L for this, for F for this, and R for this. Okay. As soon as the user print this key, and ultimately it will display this message: if a user does not press the key which is required, the compiler will went here and show the image and again wait for the user to wait for the user to press the key. Now let me run this. You can see, wait for the seconds, it will display the window. Okay. As soon as I press any key other than L, R, F or S, if suppose I press R, it show me the message down here. Let me, okay, I press the R. I have to press other key rather than for other than L, R, F or S. Let me press Y. Okay, so it will show me assist, or you can say the warning. Okay, now if suppose I press R, it does not show me message, it just printed. Okay, and 1114 basically represent the R key. And okay, so this way, previously also I have pressed the R key, it's 114. Now let me press L key. So for L, if suppose I press L, 108 represent the L key. Now this way, the while loop is running. Let me press S, whole thing will get vanished. Means the while loop will get break and the whole thing will get vanished. So this way, it is responsible to our keys and how the compiler is moving. I have explained you each and everything. Okay. Now I will explain you inside this if statement what is happening here. Okay. Till here I will explain you how which video is selected. Okay. Let me first uncomment them. Okay, so when I will click, or if the user will press L or small or like capital L or R, this function get activated, get random video, and in this function we are passing the parameter L as a side. You can say, okay, so this function will get called. Here the folder name basically the means the string, or you can say the thing which we are passing in as a parameter. Here L, here R or F is act as a folder name through which we can select. You can see inside this video folder, we have three folders, F, L and R, and each folder contains the video. Because right now I want to show you the model prediction, or the model YOLOv8 pose model, the prediction and the push-up counter on these videos. But when you will run this Python file, or you just run this Python file in your mobile desktop or your laptop, you can connect your camera with the Python file, and you can do a live demo for push-up counter, and it will count, or it can perform as a push-up counter. Okay, so here folder name, then it will, let me show you. This is the folder name. Basically, F contain 5 videos as a front. Then I'll contain 5 videos for the left side push-up, and for the R, it contain 5 videos for right side push-up. Okay. So here first it will make the path, folder path, by using os.path videos in the folder name. Then we will make all the list of the file name present in that particular folder, whether it is f, n, and l, may according to the user click. It will randomly select the file name, and after that we will make a video path, and we just return the video path. After cutting the video path, that variable, or you can say video path, is stored in this variable. Same way for the r, and same way for the f. Okay. After that, we will display, or you can say we will play that video. So how we can play this video? When this function will get called. Okay. This function will get called, and this function will get activated. Okay, so here we passing the video path and the side. You can see in a parameter, in this we are passing video path, and side means the folder name FLRR. It gives us that which side we are which side we are using for push-up counter. Okay, so let me comment them. I will explain you later what is this if statements here. Okay. Just we have to play the video. These are the variables. I will explain you later. Okay, so after getting the video path in the site, means which side we have to activate. Then these are the two variables, counter and stage. I will explain you later when we will use in this and then when the coming code that they will be used. Then we have to just pass the video path in video capture. If cap dot is open, means fail to open video, means suppose might be possible that video is not opened or video path will be not there, so it will return that function, and ultimately it will return if suppose there is an error in this video path. Now we have to play the video. For that we have to use while cap dot is open. It will cap dot read will basically read the next video frame, or they can see the frame. It return two parameters. It return the two things, ret and frame. Frame is basically the image of that particular video, or you can say frame, and ret basically it is a result. If not ret, means if ret value will be false, it means the video is stopped. Video is and counter, we update a counter value will be 0, means the counter is stopped now. We have to make it be 0, and we have to break the while loop. Then if suppose the right value is true, it means we have to resize this according to the frame size. The size which we are using is 1280 and 720. After it, we will show that frame, and if suppose the key is escape as or as, it will break the loop, and again we have to make the counter value 0. So now we have to play the video. Let me save this whole Python file, then we have to run it. As you can see, we have a window, push-up counter. Then let me select L. It will play the video for the L after selecting randomly. Then I have to press S to break this, or you can say break this while loop. Then again I have to press R to select the right side video. Then I have to press S for stop this. Then we have to press F for front side selection. So this way the video is playing. And now let me again press in this, coming to the back to the main window, and we press S, all things will get vanished. So this way we play the video. Now we develop our key points using a YOLOv8 pose detection model on our video while playing it. For that, go to the while loop and uncomment these lines. And also we have to uncomment the model. So here we are loading the model, pretend model. The model which we're using is YOLOv8 and pose PT. Okay. The best one is YOLOv8X, but right now because my GPU is not there, so for the good smooth working, we have to use YOLOv8N small version. Okay, and this way, this is a frame. I resize it just You have to give the in model.predict, you have to give the frame, then confidence you want, and the verbose, and then this will give me the results. Now to extract the key points, we have to use result 0 key points dot xy 0 extract key points. This will be extract the key points. Now we have to convert those all keywords key points in a numpy format. So here we use keypoint.cpu.numpy. Here we convert that and showing this p value. Now draw points is basically the function. I will explain later. Here I just use it just for the explanation purpose. I have used it here. Frame is equal draw point, just pass the frame and p, it will develop a key points on a frame while playing it, and just show it that image, show that video. Let me run this. So let me press L, it will play the video with key points. Okay, see, this is a key points. Okay, let me press S to stop it. Let me press R. Now let me press again, let me press F. Let me press S now, and let me press S again. Okay. Now let me explain you this two list. What is use of this two list and use of these two things. Okay. And also what is the use of these two variables. Okay, or you can see the default values. Okay. Let me explain you the use of these two things is counter. Initially the counter value will be 0 and stage is equal to up, because initially when you do push up, your initial stage will be up only. Okay, so that's why initial stage will be up. Now let me explain you this thing. For the left side, this is left side, the side indexes. What is 0, 5, 7, 9, 11, 13 and 15. When the YOLO work, you can see this is the representation. Okay. And let me make it small. Okay. As you can see, this side index, for the side indexes, 0 here, 0 here, in this 0 here, 0 indicating this thing means the nose, and same for the relative indexes, 0 indicating for the nose, 5 indicating for the left side, 5 indicating this 5, 7 here, this 7, and 9 here is this representing this 9, and 11 representing this one, 13 this one, 15 this one. Okay. And one more thing, that relative index is 0, 7, 5, 11, 13, 15 is the things which you want to display. Okay. So for better explanation, you can see this here. This I am just representing this part, and this C dots means I am representing only 0 index. This 0 index means the nose, then the 7 this one, and 5, then 11, then 13, then 15. Okay. In relative indexes for the left side, I just want to display this part. Okay. So, and what is the use of this thing? You can see here I am just representing you can see here's a connected body. First is this thing, define skeleton connection body parts. Okay. Connection body parts to draw a line between them. So when I will giving this thing, and also giving this connection body and connection body to draw the lines between them. So here 1 2 connection body, you can see here 1 2 means index value 1 2 means here 1 basically representing 5, here 2 representing 7. So line between index 5 and 7. So you can say 5 and 7 this line. So this line will draw. Same way, second index and third index. Second index means 7 and third index will be 9. So line between 7 and 9, and go for it. And same way for this, and same way for I have making this connection for the relative. So this way, the meaning of this this two lining is this is the indexes for the skeletons which the model YOLO model will detect, and this way we connect the lines. Okay, I just pass this connection body, and the side indexes, and ultimately I can draw the connections between the points, and I can easily draw the lines. Okay, same way for the right side. I will explain you each parameter. Okay, when we come to the use of them, I will explain you everything. Right now I just explained you this part because so you don't does not get confused that what is happening. Little bit step by step I am coming. Okay, let me explain you this process site function. Okay, so whenever the user click on this L button, when I will run this file, I will click on L button. The compiler will come here, and it will randomly select the video and play that video, and YOLO model will work on that video. And if suppose I press L, so side will be L, so this thing will get activated, and here I will call this process side function, and these are the parameters. You can say these are the um, 14 parameters, I think, or I think say more than 14 parameters. Okay, so this function will get activated. You can see we are passing multiple parameters here. The main thing is C, we are passing the frame, and the P, you can say P are the points, key points, which is predicted by the model. Okay, YOLO model, YOLOv8 model. This is side indexes, relative indices, connection body, connected relatives. I already explained you this parameters. Anchor index, you can say I will explain later when it will be the use. Counter, I explain you. Stage, I explain you. Initial steps will be up. Fixed start and fixed length, I will explain later. Mode, you can say mode is a L mode, F mode, or R mode. Point one, point two, I will explain later. So let me explain this thing. When I will compile, will come run this. Then when I run this Python file and the user click on L button, basically L button call this cat random video variable there. Here be a call run pose detection. We are passing the video path and side will be L. This function will get activated, and here we just randomly play the video, and here when we randomly play the video, we are calling process side function. If I user click on L button, this if will get activated, and process side function will get activated, and here first thing will get happen is side point, extract side points from side indexes. Using the side indexes and the P, we extract the points, side points. Okay, and same way for the relative points, we extract the relative points here. Okay, you can say relative points and side points, you can say coordinates values. Okay, for example, if suppose this is a left side posture, so coordinates value for the side points will be this thing, 0.1, 0.0, 0.1, this way. Okay, so this point will be extracted easily. After extracting the points, we first go to draw points. Okay, so you can see from utils we extract draw point function. So we will go to utils, and here we call see the draw points function. So this is the function. Here you can say we just passing the frame. We are passing the frame and the side points. So side points will be this thing. So points, after getting the action point, we will make up points here. From we iterate over the points, pt, we get the points. So pt0 give me x value, pt1 give me the y value, and we convert them into int. Okay, after that this is a scale. This both have a scale, and 0 for these are the colors, and -1 just we you can say filling. We can say uh, green color is filled, and there is an outline of pink color. So here, here is -1 is just a filled one with a radius of 7, and with a radius of 10 we are making the border using a pink color, and 2 just we do not want to fill that. Okay, so this way we draw the points. After drawing the points, we want to connect these points. You can say after drawing these all these points, we want to draw this connection, this connection to this point to this point, 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 this point to this point. So how we can do it? Just you just in draw connection, you have to find frame, then the side points, and for the side points we use connection body. You say this is a list connection bodies. After getting this, it will call to draw connection function. So from utils we go to draw connection function. Here we just pass the image, then the point, then the connection on which we have to draw. Okay, so here 4k ij in enumerate connection, we enumerate over it, we can say over loop over it, and just using the k, because you can see in this list, I have make a one connection, unique connection is between one from connection 1 to 6. Here 1 is representing 5 and 6 is representing 15. Okay, So 5 and 15. So what is it? Let me show you. So here one, you can say here one is 5 1 5. The 5 is this thing, okay, this one, this point, and 615 is this point. So we are making connection between this line, this point to this point. So I am just making this last point, last connection using this 1 and 6. So that's why I have used here k for, or you can say that's why I use enumerate. So that's why when there will be k is equal to length of connection minus 1, it will change the color, and else connection will be of white color. You can say the difference is this thing only, that a main line is of red color and other connection will be of white line. So I have to just change the color here. Okay, say this, I just make the color changes on color. That's why image draw, just use the draw line, then the image, then we just pass the point 0 and point j. Okay, this I and j and the color. This way we'll draw the connection between them. So let me show you this, what is happening here. Till here I want to show you, so you will not get any disturbance. So let me make comment over it. Let me save all this thing and let me run this. Okay, just we draw the connection and draw the points here, and nothing else we will draw. It will take a time, so wait for it. Okay, so let me show you. So suppose I click on L button, it will randomly select the video. You can say this, it will randomly select the video for the L's from the L folder, and it play the video. I think it's not responding, but wait for the seconds, it will play. Okay, you can see it's playing, and only connections and points will be there, nothing else. We are not use any push-up bar, counter, anything, just points, drawing the points and the line. Okay, so this is, let me press S, and now let me press S again, and we have closed everything. Now let me explain you other functions also. Now let me explain you how you can calculate the angle. For that, just we have to, you can say here I'm just using the cat angle function, passing the frame, and anchor index means the shoulder, then the elbow, then the, you can say the wrist. Then how you can, let me show you that what is happening here. You can say when I will click on L here, and the anchor index value will be 5. Here 5 basically representing, here 5 is basically representing this shoulder, and when you will do anchor index plus 2, it will represent this elbow, and 5 plus 4 representing the wrist. Okay, so 5 plus 4 basically representing the wrist. So shoulder, then the elbow, then the wrist. In using this 3, you can say using this 3 points we will calculate the angle between this. Okay, so for that we have to use get angle, and here just passing the frame and this 3 points. So in utils we will passing it, and this function will got called. Here we are just passing the 3 points. Here there will be color which we will use to display the angle. This is a thickness and this is a font scale. So this is a, you can say this is a whole calculation. This is a whole calculation, and this whole calculation in single word I say this is a dot product. Using a dot product, I am calculating the angle between the 3 points. Okay, so what is happening here? Here we are just first converting the points in NPy NumPy array, and for the better explanation, I have already make a graph, or you can say, yeah. So here you can see, first thing that we have to convert that into the vectors v1 and v2. So here we are just converting, this is the, we can say, defined vectors v1 and a2 means a minus b and c minus b. Using this we have calculated it. Here you can see here a basically point a, point b, a minus b, and point 3 is, you can see, c minus you can say c minus v. So this way we calculate the vectors. After calculating the vectors, we first normalize them. Okay, compute the magnitude, or you can say magnitude of both vectors. So here this is computing of vector magnitude. Okay, 142 and 112. After computing the vectors, we then normalize them using the v1 length and v2 length. Okay, After normalizing them, we will get this thing. Okay, normalize vectors. After normalizing them, we will compute a dot product. So here is the dot product, and dot product will be 0.316. Here you can say minus 0.316. Okay, you can say it minus 0.316. Now after that, we will clamp the dot product using with the valid range -1 and 1. So we will clamp that. Here after clamping, it will be minus 0.316. Okay, sorry, not yes, minus. And after minus, we will just compute the angle using the across. We will compute the angle, and the angle is in a radian format. After that, we have to convert it into angle format, and after that we have to convert that into, or you can say round off we can do. So the whole thing is happening here. After calculating the angle into radian, then we have to convert that into radian. After radian, we have to convert that into the rounded angle 108. Okay, so this way we calculate the angle. After calculating the angle, we just put that angle in using this here point 2. Basically the point 2 is this thing 7.1. And for better explanation, let me show you the picture for the left side. You can say point 2 is this thing here. This is a point 2, and we are just displaying just x-axis. Okay, we have to increase the x-axis value to put text. So that's why just using the point 2 0 x-axis and increasing the value. After that, there is a font, there is a font scale, then the color, then the think text. After that, we just returning the image and the angle with it. After returning the frame, you can say we have got the frame and the angle, and after that we just display that. What is the use of this angle? Because using of this angle, we will means using of this angle, we will count the, or you can say count a push up. Okay, basically the condition which we use to count the angle, oh sorry, count the push up, is one thing is using this angle. So we will not use here what is use here how to means we are just computing the angle. We will use it this angle later. Okay, now let me explain you this function. It give me the align points, means the points which you want to display on the top of the frame. For example, let me show you this image. So through these points, I want to get this points so that I can display this alignment here also. So how I can do that? Let me explain you. So this is utils where it is. Okay, so this is a whole function which give me those points. There is a mathematical calculation is going on here. So I will explain you each and everything here. Okay, so how you can get this? For this, I have already created one code, separate code, just for your explanation purpose. Okay, so this I have taken randomly the points. Okay, I have created one. I will not explain this whole code because just this is the same code. So let me run this. Let me first comment the whole other things. Okay, so let me run this one file. As you can see, this is your you can say this is the example that the model is predicted this thing. This is a left side push up. Okay, now we want to get it, the function will be called. Here you can see we are just passing the relative points. Okay, then the point 1 and point 2. Point 1 is basically representing the anchor, or point 2 is fit. And for your better explanation, you can see point 1 is 5 and 15, and 5 is representing the shoulder and 15 is representing the fit for the left side. Okay, so and then frame, then the mode, like right now the mode will be L because I am just explaining the left side, and same way is for the right side. Okay, but a little bit different with the you can say with the app, but it's not that much difference. Fixed start, you can say fixed start is basically you can say the y coordinate or y coordinate from the above, means you can say how much y coordinate will be there. Then fixed length. Okay, so this thing point fixed start will be none right now because fixed start is basically used only when the mode is F. Okay, but right now is mode is L, that's why it will not be used. Now fixed Y means the, you can say the gap from the top, means this one. This is a 50 pixel gap here. This is, that's why fixed Y will be 50. Fixed length, this much. Here it is length is 600, but I want the fixed length will be 400. So okay, this way. Then the padding from the above, I want some padding. Okay, so that's why 50. Okay, so let me first is we get height and width of the frame. After getting the height with the frame, we count the vector of the vector of the lines. Okay, point 1 and point 2, we will find the vector of those. Okay, which help in calculation of the length of the original length of that particular line from the shoulder to the feet. The line we have to calculate the length. So this way we calculate it. For the calculation, we also find the vector. So this is the vector which we have calculated. Okay, now let me show you dx and dy, how it is representing. You can say it's a direction vector from point 1 to point 2. Okay, so let me run it now. You will see that this is the dx and dy. Okay, now after getting the original length, we have to find the center of that particular line. Okay, so I have to, this way we calculate the center of the line just to use point 0 and point 1 point 20 that added divided by 2, point 1 point 2 divided by 2. You will calculate the center of that line. Okay, so let me represent that center of the line. Okay, so this is a point 1, the shoulder, point 2, this is a, you can say, fit, and this is the center of this line. Green point is the center of this line. Now let me comment this. We don't want to display dx and dy, and also we do not want to display the center. I have already explained you. After calculating the center, we have to find the angle, and dy or dx. This way we pass the dy and dx, and we count the cantilever. You can say angle. Angle is calculated using dy and dx. You can say vector direction vectors. So this is the angle is minus 9.191 degree. Okay, this is minus, and minus is because we have to rotate negatively. That's why minus 9.91 we are representing. And you can say in calculation also I am using minus, so it's basically that one. If suppose I will not use minus here, it will be 9.9 degree. Okay, let me cross this. I have also shown you the angle. And one more thing, let me explain you that this angle is calculated from point 1, and we draw this line here, and we draw parallel to the x-axis, and we calculate the angle using this formula math.tan to here. So this way we calculate the angle. After calculating the angle, we have to develop the rotated points. How means basically we have calculated the angle just to say that how much we have to rotate the rotate whole points and make it aligned to the, or make it say parallel to the x-axis of the frame. So this way when we will loop over the points and call this function rotated points, this is the function which give me the points which can rotate each point according to an angle which we have calculated. So after getting these points, okay, after getting the points, I have to show you so how this points look like. So let me run this. This is the points, you can say these are the points which is calculated after rotation. Let me save it and show you the result of this after getting the points which is rotated now. Okay, what is problem here? Let me see. Let me save it again and run it again. Okay, so this one, this green one, this line is basically the one which is calculated by the model, and this is the thing, this is the this blue line. Basically these are the points which is calculated by us after rotating each point through the angle to make it parallel to the x-axis. Okay, now we have to find, so this right now for your explanation. See here now you can see this after rotation. You can see rod point 1, rod point 2. Here also we are using the rotate points, just passing the point 1 center, then angle. Point 2 means we are finding, sending this in that function point 1 we get this point, sending this point 2 we get this point 2. Now we get point rotation point 1, rotation point 2, and we have to find the center of it. But you can see that for this point 1 and this point 2, the center is same, and this line, this blue line and red line have the same center. But we have to again calculate it just say, using the same method, the rotation point 0, rotation point 2 divided by 2, rotation point 0 and divided by 2. We will calculate it and just display the center using the rotation points. We will find the center of that line. There is no need to draw draw these lines now. there is no need to draw these lines now, because after rotation I have also already calculated it. So after rotation, our points just look like this. Now we have to also calculate the center. So this is a center. Oh, I think so. We have not closed it. So let me close it. Then again, I have to run this. Now we have to get the center. Wait it. So this is the center now of the new line after getting the rotations. Okay. After getting the center, let me comment it now. We have to find the scale. So what is a scale here? You can see. Let me run this and show you what is the meaning of scale here. See, our fixed length is 400, means here above I want all length of the line in 400 meter 400 pixel length of line. I want all the points to be there. So fixed length will be 400. Original length means this blue line will be length is will be 698. So scale will be 0 0.5. 0.5 will be the scale. Fixed length and original length means how much the fixed length is smaller or greater than, or how much the original length is smaller or greater than the fixed length. So this way we calculate the scale. The scale basically help us to get the points, or you can say analyze the points or decrease the points calculations. So after using the scale variable, we will calculate the scaled points. So this way, scale point will get created, means you can say scale all rotated points outward or inward related to the rotated points. Okay, so this way, are you using our scale? We can calculate the scaled points. Now let me show you the scaled points. As you can see that when I run this, right now they can say this is a enlarged. Now let me run it again. Now we will get the uh, oh, overlapping is there. So let me erase it is this one. Now I have to align all points in 400 centimeter. Okay, not 400 centimeter, 400 pixels. So after getting the scaled one, I will get a, see, all points are now scaled. All points are scaled in this small 400 pixel length of a line. Now we have to shift this whole thing here. So how we can do that? So how we can do it? Let me comment this now. You have to display this only. So if right now the mode is F, so there is no, I will not explain you this right now. The mode is else, so this line, this else will be calculated, and shift X and shift Y. What is happening here? Okay, let me comment, and now see how we calculated. We have just divided by width of the wide, means I want to display. Uh, I want to display that line, means uh, I want to display this whole dot points at the mid of the frame, from the x-axis. Okay, so how we can do it? Just width divided by 2 and rotation x and fixed y, mixed by the mean 50 pixel, then rotation center y. So what is this representing? Shift s and shift y means how much pixel value you have to decrease in x-axis and y-axis. This line is represent this thing. How much? So let me run this. Now let me run it. See, our initial W/2 x value will be 640, fixed y will be 50, this much. This is center, and rotation center x will be this thing. Okay, so for wonder this said. So this is a center for the rotation, and this is center for me. Okay, so I want how much the center should be, how much the center has to be fixed, means shifted. How much center have to fix, how much this center will be fixed to this center, how much this is calculated by using shift x and shift y. Okay, minus 10 and minus 6. Okay, this values we have to separate it. So after calculating this, you can see I have added x plus shift y, y plus shift y, and I have get the shifted coordinates values. Now let me show you this thing now. After getting shift x and shift y calculated values, you can see my whole points are shifted to here, related to the center to this line. That's why we have calculated shift s, and shift y. Up now, it might be possible. You can see it might be possible that it might be possible that the y coordinates for all these points go out of bound of this frame, or the y coordinate or the x coordinate go out of bound of this frame. But we do not want that, and also we want some padding from the above. So how we can do it? We can use this thing, this 4x minimum and max. Using this, I can make sure that all the points will be in a frame. Okay, this thing you can see, read this line, ensure all points stay within the frame. So this line basically give me, and after that we'll get the points, okay, which can be displayed on the top of the frame. So let me show you now that thing. There is no need to show this point now. I've already explained you everything. I will little bit explain you one more time. Okay, we get a better explanation. So this thing is represented by here. Now let me explain you again. And when this function is called dx, we calculate the direction vectors. After calculating direction vectors using point 1 and point 2, one more thing, that point 1 is the shoulder and point 2 is the feet. Origin length, you can equivalent distance, we can calculate the origin length of that. After calculating, we find the center of that particular line. After calculation, we find the angle. After calculating the angle, we will rotate all the points, and after rotation we get the points, rotated points. This way we get rotated points. After calculating the rotation point, using the point 1 and point 2, we calculate the new rotation point 1 and rotation point 2. After finding that rotation point 1 and rotation point 2, we will calculate the center of that new line. After getting the center of the new line, we have to find the scale, mean how much the line is small or greater than is that. About the fixed length which is decided by the user. Myself I decided pixel will be 400 pixel value. Okay, so length of that particular line. Okay. Now, after calculating it, you have to give scaled. Means we have to calculate the scale. We have to get the scaled points. So we have to display those scaled points. Okay. Now we have to shift those all points above in the frame. So that's why how much we have to shift. This is decided by shift x and shift y. After calculating this, we have to after doing the mathematical calculation, we have to get all the shifted points. And one thing is also left here, that it might be possible that the y coordinates, the x coordinate go beyond the frame x and width and height. So we have to decide that also. So this line will ensure that all points will be in a frame. After getting the relative point, we will display that. So this thing is happening here. One more thing now is, suppose mode is equal to f. As you can see that in mode f, if suppose there is a mode f, I have displaying one frame, one point, so align point will be here and one align point will be here for the left and right. So that's why fixed start is basically used when there will be f will be there. Okay, if mode f will be there, only that time will be activated, and all the things remain the same. You can say the scale point is calculated this way, and shift x and shift we have calculated. So basically fixed start is used when I want to display f mode push-ups. Okay, so this is a calculation which I have explained you. So go to the main. Okay, and you will call this relative points, fixed start, fixed length, point one, you will get this utils use this thing will calculate it. Okay, all thing will be remain same, everything I have explained you. So when you will run this, we have to draw those points. So let me explain this thing also. Okay, here I am just passing this align point from 2. I am just passing, not from 0 1. Why? Because you have seen that oh, where it is, yes, this one. You can see that here I am oh, this is not this is not this, where it is. Okay, suppose I am displaying all align points x. I'm not going to let me run it now. So 2 extra point will be displaying. See, this is a point for the nose, and this is this is a point for the, you can say, the elbow. So I don't want to display, I just want to display this thing, this 1 2 3 4 points. So how we can do it? Just use uh, start from 2 and rest points. So this way we can do it. So this is the thing which we are doing here. Okay. So let me run it now and show you the result of that. If suppose, let me run it now. It will take a second, please wait. Okay, it's coming. If suppose I click on Al, wait for the seconds, it will show play the video. See, yes, it's playing the video now. So this way we're getting it, the points. Now we have to draw the bar here for up and down. Okay, let me press S, let me press again S. Okay, now I will explain you this thing. So we will draw now push-up bar. So drawing the push-up bar, we will use just pass the frame and the angle which we have calculated. See, okay, from the you can say angle between the shoulder, elbow, and wrist, we have calculated. We have to pass it here. Draw push-up bar. To draw the push-up bar, we have to pass here and also in this counter. Okay, so in utils, you can say this is draw push-up bar function. This whole code, but I will explain you in different way. Bar explanation. So come to here. Okay, so as soon as the angle is calculated, we call the draw push-up bar. If now right now the angle will be 90, let me keep it to 95. And here, oh sorry, 95. And you can see in draw push-up bar, you can say you are passing the frame and angle, and minimum angle is 95, and maximum will be 130. So what is happening here? Why we are clapping means we are ensuring that the angle should be in a range between 195 and 130. What is this? Suppose my angle will be less than 95, it means my angle will be 90 now. If suppose I run this now, you can see my whole down will be filled, means less than 95 or less than minimum, that means the whole push up means down position of that particular person. Okay, so that's why it filled that the whole thing, whole rectangle of down one. Now if suppose you can say maximum angle is 130. If suppose my angle is greater than the maximum angle means 150, it should 150 or 140, and it makes sure that bar should be filled up, upper bar should be filled completely. So that's why 140. So if suppose 140, my upper bar will be filled completely. Okay, now let me explain you minimum angle. Is suppose same way, if suppose minimum angle, my angle will be 90 degree, so 90 degree and maximum angle is 130, so my 90 will be selected. Now 90 is selected, and 90 and minimum angle 95. What is this? 90 means angle 95 will be selected. And same way when 140 will be there, so 130 will be selected, which makes sure that when the angle is in a range of 95 and 130, or you can say go beyond the 130 or less than the 95, our rectangle bar will be filled, half bar will be filled. Make sure that's why. Then this is bar x value, this is the coordinates value. You can say this is a from x 30 pixels gap. And how we can calculate the bar, y is calculated like that. Means you can say, you can see that this whole rectangle is at the center of, so we want that the bar should be at the center of from the related to the y axis. So that's why we calculated frame shape 0, means you can say give me x value minus, so not x value, you can say y. So image dot shape 0 give me height. When you divide minus the bar height means this 200, and divide by 2, we get the y coordinate, which can vertically center from the related to the y axis. Okay, then the width will be 30 and the height is 200. Now in empty we want to display this color, and when we go up, red color will display, and when we go down, green color will display, and the outline color will be 50-50. So you can see outline color this and up and down. Now we have to display the text. So this way we display the text bar x and bar by minus 10, bar x minus 10, bar by plus bar height plus 25. Give me the, you can say the dow coordinates. Now you will don't get confused. Let me explain you. Let me first run this and show you the how this all things calculated. Okay, let me close it. I'll show you the image now. Now we have to put this up here. So how much this gap? This is bar x. You can say bar x is, you can say the bar x is 30. Okay, 30, and bar by minus 10 means bar by this one. Bar by is, you can say bar by is center this coordinate, and we want some gap, or we can say then the padding from the upper padding from the rectangle. So bar by minus 10 means it go to here. So that is this way we calculate the bar x and bar by. Now how we calculate for the down? You can say bar x minus 10. Down is greater means that we have to decrease this gap here. So how we can do it is bar x minus 10. So this point will come to here. And for the y coordinates, bar y means this one, bar y is here. We are adding bar height, it's come to here. Now we have to add some padding means 25, it come to here. So this way the calculation is coming. Okay, after getting it, we are putting the text. Now we have to find the mid angle, because the whole thing is happening or you can say mid angle is at the saturate point, or you can say the condition, you can say. Okay, let me write it again. You can see that mid angle is acting as a saturate point or the condition point. So how we can calculate it is just minimum angle plus the maximum divided by 2, we get the mid angle. Then half height, how we can calculate this? Bar height divided by 2, we get the half height. Now if suppose the angle is, if angle is less than mid angle, means we going down, means a person is doing the push up and its going position is right now is down position. So we have to fill this green color, so how much we have to fill, how much area we have to fill from the midpoint to the down is decided by this two line. Okay, this two line decided by this ratio and fill. Ratio give me how much, and when we multiply by this ratio, we will get the how much we have to fill. So for your example, let me show you that how much we are getting it. Uh, let me do it 100. Okay, and then run it. Okay, and you can see after getting mid angle minus minimum angle, we get the ratio. After getting the ratio, we will multiply it with the height, half height, and that area will be filled. So how we so let me show you how the rectangle is filled. Now we have to draw this green rectangle. So frame bar x. Bar x will be, you can say this one, means x coordinate. Now how we can get a pi coordinate? Just use bar by half y, we will get this coordinate. And you can say in rectangle we have to give top left coordinates and bottom right coordinates. So top left will be bar x, bar y, bar y. This coordinate will how we can get this coordinate, bottom right coordinate. So how we can get it? Bar x, then we add bar width, we get the x coordinate for this. To get the y coordinate, bar by means you can say bar by plus half h, bar by plus half h plus fill, we get the bottom right coordinate of the rectangle, which is filled with green color. And same way we will do for the red color if the person is going up. Okay, now this is, we draw the outline here, bar x, bar x plus bar width plus bar by height. This way we draw the rectangle outline. So this way the whole thing is working, and how we are doing for the calculation. Let me for the better, let me now print ratio and print fill if the angle is greater than mid angle. If suppose, okay, so if suppose let me angle will be, let me select one angle, will be 120. Okay, so let me write it now. Okay, it fill up, and you can say the ratio is 0.4 and 44 pixels values are filled in this rectangle. So this way the calculation is going on and how we have calculated how this will draw the bar. So same thing is happening here. When we draw push-up bar is calculated, or if you say called, we go to here, draw push-up, angle will be 95, maximum 150, and the whole calculation remain the same. Now we have to develop the counter. The counter, how we can do it, how we have to condition which I have applied for representing the counter. Okay, so as soon as push-up bar is there, align points are there, everything will be there. Now the main thing is to draw the push-up counter, means counter thing. So here we are passing draw counter frame angle, which is important. The counter initial value will be counter will be 0. Stage initial stage will be up. You can see stage initial stage will be up. Align points means the points values, and you can say, and it's also return frame counter stage, because these values counter stage is responsible for, in we can say, for tracking the person. So as soon as this function is called, in utils will go down and draw counter function will be called. Okay, so here pass image angle counter stage align points. First, this font is decided here. This font is this one, which we use for input text. This is a color which we use. Okay, 255 white color to display the text of the counter. Now if counter is less than 10, scale value and thickness value will change, and pause position will also change. So this is not just for the related to you, just this is the thing which I have decided or is calculated and is shown here. Okay, so scale, thickness, position, this all things I have calculated already. This is not just for the explanation purpose. This is not very important to explain you. Okay, one more thing, that counter is less than 10. If counter is greater than 10, or you can say 100, you can say the thickness is decrease, the scale, or everything will be increase or decrease, they will be there. Now this thing is by position of area. Okay, nose y, elbow y, this from a line point we have extracted. Okay, now angle, this thing is important. Nose y, elbow y. As you can see in this cell, when we do a complete push-up, this point, this nose will go down, to the elbow. From the elbow, when we relate this nose from this elbow position coordinates, you can say that node position will go down from the elbow position coordinate. Let me show you one example for the left side. In every video where it is, yes, see this one. As you can see, at a complete push-up, when we talking about the complete push-up, you can see that this nose position is down to the elbow position, and this is the one condition we will use. Okay, we can say that this is a complete push-up. So this is what we are using here. Okay, if suppose angle is less than 95, it means yes, push-up will be going on. And one second condition, elbow y should be less than nose y, and stage is up, initial stage should be up. And you can say, you will get confused that what is happening here. Elbow y will be this one, or come to here, elbow y will be here, and nose y will be here. And one more thing, in the OpenCV, 00 coordinates or y coordinate, 00 value start from top left coordinates. According to that, if y value is less than nose y value, we can say that nose is down to the y, elbow coordinates. So that's why elbow y less than nose y, and stage will be up. We can say complete push-up is going on, and now we have to convert the stage will be down. And as soon as the angle is greater than 130, means up position is coming, and the push-up, complete push-up is completed, means actual push-up is completed. Okay, and we have to, and that time stage will be down. Okay, and stage will be down because this we have, because first condition, when angle is less than 95 and LOY knows this, stage will be up now, but now this time stage will be down. And we compare this position, or this position is coming in this video, you can say at this time your stage will be down. As soon as the angle is greater than 130 and stage is down, we can increase the counter and stage will be up. Now the stage will be up, means the initial position of the person is up now. And according to that, we will display the, you can say, to the quarter circle, means this pink circle, and inside this pink circle we draw the counter. So this way we calculate the push-up counter, or you can say counter of the push-up. Again, let me explain you one more time. Then an angle is less than 195, elbow Y will be less than 90, and the stage is up. We can say that person is going down, and we have to change the stage position, and the position is now become down. As soon as the stage will be greater than 30 and the stage is down, we change the counter value and stage value, and this condition ensure that the complete push-up is completed. So we display that counter value and the quarter circle. So this way it is working. So I have explained you for the L whole thing, and same thing is happening for the R. Okay, same thing is happening for the R, but little bit different for the F here. Little bit different for the F is that here I am just using fixed start 690/50 and fixed start 690/50 for the F. Okay, because I want to display both you can say both align points for the left and right for the front side push-up, so both will be displayed here, and all things is calculated. Fixed start calculation is done by me. Okay, so now let me run this file, wait for the seconds. Now let me press L. You can show the preview, but right now it's using a nano model, so you can say the accuracy will be some little bit different. Okay, I use X. I have already used X model in somewhere and downloaded the videos. Okay, or you can say save those videos, which is representing the X model. Okay, let me press S again. Now let me press R. Okay, working well. Good. Perfect. Now press S again. Now press F. In F, we can say there will be some little bit not good much. I'm thinking that I will not display this two lines in F, because it's making some not good for that, not looking good. Okay, but counter is working perfectly good. Okay, you can say that as a person is moving up, you can say the counter get one. Okay, so now if you press us again, you can see that here I'm randomly selecting the video, but you can connect a camera and you do the push up and the counter will get started. Now let me show you the result. These are the result. You can see these are the example of all the videos which is trained on YOLOv8 X model, not a nano model, X model. Now let me show you some F videos. Let me show this one now first. Okay, 1, 2, 3, 4, 5. It's perfectly working. Now let me show you one example of L left side. Let me select this one. 1. Push-up bar is also working well. Good. 3, 4. Perfect. Now let me show R. Select this one. 1, 2, 3, 4. Okay, so working well. So this is a push-up counter which I've explained each and everything. I will provide the whole thing to you. Okay, especially the videos for the better explanation. So please like, share, and subscribe. Thanks to all.